Okay, so now we will deal with collisions. Now, the collisions being either 1D or 2D is managed with that is known as the conservation law of momentum, which we just mentioned before. The conservation law of momentum is stating in an isolated system, the momentum is conserved, meaning that the vectorial sum of momentum before is equal to vectorial sum of momentum after. The common mistake that the students do is that they do not add them vectorially. However, keeping in mind the fact that momentum is a vector, we cannot add those two vectors or more, if there is any, using just the magnitude. We have to take into the consideration the fact that momentum is a vector. Let's see now some examples on, as to how can we figure out the velocity either before or after of one of the objects. So let's suppose that we have an example in which object 1 with mass 1.23 kilogram is moving toward object 2 with a velocity that is, let's say, 25.3 meters per second going east. And object 2 that has a mass of, let's say, 2.35 kilograms is at rest. When we say is at rest, means that the velocity of that object is equal to 0. So a situational diagram after the collision, well, let's say this is the before the collision, and after the collision, object 1 is moving with a velocity of 12.3 meters per second going, or let's say at 30 degrees north of east. What is the velocity of object 2 after the collision? Again, when we see this prime, that means that we are dealing with the velocity after the collision. So this is the before situation, and this is the after situation. Graphically or situational diagram of this particular question will be something like this. I will make them with 2 different colors so that you can see. So object 1 with mass 1.23 kilogram is moving toward object 2 with a velocity of 25.3 meters per second going east. And object 2 is at rest with mass of, what was it, 2.35 is at rest. This is the before situation. And then for after, object 1, we are saying that is moving with a velocity of 12.3 meters per second. So object 1 is moving with a velocity 12.3 meters per second at 30 degrees north of east. And we don't know where object 2 is going right after the collision. So now the assumption here is that the system is an isolated system. How do we know that we have the right to make this assumption? Because the velocity of object 2 after the collision is not given to us. And we know that on those cases, we will assume that we are dealing with an isolated system. When everything is given, the mass and the velocities before and after are given, then the question will be what type of system is it. But on the case when you are asked to find the velocity of one of them, either before or after, then the assumption is that we will consider the system an isolated system. Since it is an isolated system, the conservation law of momentum is true, which means that the sum of momentum before is equal to the sum of momentum after. When we see this, what do you think? Is this a 1D or 2D situation? So the question, or what you will look for, is any of those vectors. So velocity 1, velocity 2, velocity 1 prime, velocity v2 prime, are they forming any angle with the axis, northeast, southwest axis, any of them, or are they along one of the axes? This is the question that you will ask yourself. So is this a 1D or 2D situation? It's a 2D situation. And what do we do on 2D situation? We build the table of components. Now this is a easy one, but this is the logic that we will follow on every time that we are dealing with the collision, either this being a 1D or 2D. So we always will say, okay, assumption is that the conservation law of momentum is true, which means that the system is isolated. So now, is it a 1D or 2D? It is 2D. If it is 2D, then we build the table of components. Look how I will suggest you to build the table of components. I will suggest you to build the table of components for the before and after side by side. So when we have the before situation, we have horizontal and a vertical, and then here we have P1, P2, and the sum of momentum. And then I build side by side. I built the after situation. Horizontal and the vertical, P1 prime, P2 prime, and the sum of momentum after the collision. And then I calculate momentum of object 1. So we have 1.23 times 25, 1.23 times 25.3. Magnitude will be 31, so momentum of 1 will be 31.119 kilograms meters per second, so going east. What is momentum of object 2, since it is at rest? Will be equal to 0, correct? And now, for momentum of 1 after the collision, we will have 1.23 times, I think it was 12.53, times 12.3 will be equals to 15.129 kilogram meters per second at 30 degrees north of east. Remember what we said, that when we are calculating momentum knowing the vector in the previous class, we can calculate magnitude of the momentum just by multiplying the two magnitudes together, because the direction of momentum and direction of the velocity will be the same. Okay, so now we have momentum, so we don't know what momentum 2 is, and this is what we will focus on. So now, having momentum 1 as 31.119 kilograms meters per second going east. What is the horizontal component and what is the vertical component of this moment? Okay, so the horizontal component of P1 will be positive 31.119, and it's fine even to do 31.12. It will be okay with the calculations because neither the diplomas or the tests are not penalizing you for not rounding for that many digits after the decimal point. And the vertical component will be 0. The horizontal and the vertical component of a vector that has a 0 magnitude will be 0 as well. So 0, 0. And notice here, we are doing the same thing as we do when we add two vectors together. So then, by adding the horizontal components, we will have positive 31.119. And by adding the vertical components, we will have 0. Now let's move to the horizontal component and the vertical component of P1 prime, which is, again, P1 prime is a vector 15.129 kilograms meters per second at 30 degrees north of east, which is a vector that has a magnitude of 15.129, and the angle with east axis is 30 degrees. So what is the horizontal component of this vector? What we will do, we'll do the same thing as we have done with every single vector for as long as we have been doing physics. We'll create the right angle triangle that includes the given angle. Whatever is along the horizontal will be the horizontal component. And whatever is along the vertical will be the vertical component. Since the horizontal component is adjacent, then we will figure out the horizontal component as cosine 30. And this will be 13.1021. It's fine. You can carry on 2, 3. It's fine. Digits after the decimal point. Now, is this horizontal component a positive or a negative? Since it is going along the east, will be a positive value. Great. And to find the vertical component, we will use sine because the vertical component is at the opposite of the 30 degree. And this will be 15.129 times sine 30 equals to 7.5645. And now, is this positive or is it negative? Since it is going toward north, is it considered to be positive? Now, we do not know what is the horizontal component and the vertical component of the second momentum of the second object. Therefore, something that we do not know what is it, in math and in science, we assign it as a variable. So you can say an x, you can say an h, you can say P2 prime h, you can say anything that you want. For simplicity, I say just x and y. So I say that, well, horizontal is x. I don't know what is it. And the vertical is y. I do not know what is it. However, I follow the same logic. I say that I'm adding those two vectors together. So when I'm adding those two, I will have a horizontal component of momentum of the objects after the collision as positive 13.1021 plus x. And the vertical will be positive 7.5645 plus y. Now you may say that, well, Miss, the vertical is negative. Don't worry about it. Math will tell you what it is. You don't even have to think about it anymore. Okay, you don't even have to think about it anymore. Why? Because math will tell you what. And how is it going to tell you? Now, as I mentioned, two vectors are equal to each other when the components are equal to each other. So from the horizontal component, we will have, from the B4, we will have positive 31.119 is equal to positive 13.1021 plus x. And we know that x is the horizontal component of momentum of object 2. And from the vertical, we will have 0 that was before is equal to positive 7.5645 plus y. So therefore, what we have done is we have created two equations. Equation 1 that is as a result of equaling the horizontal component of the before and after, and equation 2 that is as a result of equaling the vertical component before and after. So now from here, we can find that x is equal to whatever is 31.119 minus 13.1021. And this will be positive 18.0169. And from the second equation, we'll find that y is equal to negative 7.5645. And if you want to either state the units, those will be kilograms meters per second. Why? Because x and y, we assign them to be the horizontal and vertical component of object 2 after the collision. Now that we have the horizontal component and the vertical component of momentum of object 2 after the collision, we can plot them, and same as we have done to compose a vector. So the horizontal component is positive, means that it is going along the east axis. So this will be positive 18.0169. And the vertical component is negative, so we'll be going south and will be 7.5645, which tells us that momentum 2 will be, after the collision, will be a vector that looks like this. Now we can find the magnitude of momentum of object 2, or simply P2 prime, as the square root of 18.0169 to the power of 2 plus 7.5645 to the power of 2. So the magnitude of momentum 2 prime will be 19.54 kilograms meters per second. Okay, meters per second. And the angle that is forming with the horizontal, you can go with the vertical, but this is something that I always go horizontal and then vertical, and then I do the angle. The angle theta is the inverse tangent of 7.5645 over 18.5645. 645 over 18.0169, and then the angle will be 22.78 degrees. So you can say if they are asking for momentum of object 2, will be 19.54 kilograms meters per second, or you can stop at 19.5 to consider the correct sig digs, but you know that now, at 22.78 degrees south of east. But the question is not asking you to find momentum. So if they're asking you to define momentum, then this is what you will do. But the question is not asking you to define momentum. It is asking to define the velocity of object 2. So here, when you take a look at this, would be what is the velocity of object 2. Now, as we mentioned, the other class is that momentum and velocity will have the same direction. So we don't worry too much about the direction of velocity 2 after the collision. However, the magnitude of velocity of object 2 after the collision will be 19.54 kilograms meters per second over 2. I think it was 35 kilograms. So kilograms and kilograms is canceled out, and then we will have divide by 2.34, 35, 19.54 divided by 2.35 is 8.31 meters per second at 22.78 degrees south of east.